ballroom A.
Okay.
In the dongle for HDMI to Ibis.
Okay, I got one. Here, let me. You show probably 315 because we're in ballroom A right now.
Ah, okay.
Yeah, so 315, I think. Let me tell you.
What's the?
It's another.
Probably. Do you want to check our notes?
Because it was flickering and now it's like not doing anything at all. So I wonder if it's...
Oh, they're doing Linux. Okay. It could be that they haven't activated the signal. Sometimes they need to do that from the actual machine itself.
Okay. When they plugged in earlier, it was flickering, and now it has stopped. So I don't know.
Okay. Is this one of your machines, folks?
I believe it's, yeah.
Sir? We just want to make sure it's actually sending signal.
Oh, sure. Okay.
Instead of, we got to maybe replace cables and whatnot, but...
Probably need to like...
Use PC to HD. Yeah, we're already on that one.
Okay, turn it off and then turn it back
I'll
on
be back.
again.
Okay.
There we go.
It's not sending consistently. I wonder if it's a power thing. Retrieve URC power. How old is this laptop? I'm assuming
A couple years.
Oh, a couple years?
Yeah.
That's the issue.
We can also use a different laptop because this is all sort of like online and shared on
Okay.
GitHub and stuff. So we can try another laptop.
Can we try that and see if maybe
Yeah,
it's the laptop?
totally.
There is, and and sometimes it can be like a power issue, or there's a bunch of different things. It could be. We replaced the cables though, so we're getting that knocked out. False alarm. My apologies. You're also 260. Great.
All right.
Password? No, that's private. Okay. Give me one sec. A couple things before. Public. Okay. I need to actually, before I forget, turn, what is it? Where is it? I never know what is it. Screensaver. No. How do I? Do you know? I mean, I always forget. Where is the? Not let the screen lock. I think.
Is this on Apple?
Yeah. I think. Okay, this one. Turn display. Sure. I think okay. I think that should be done. Let's just put some. Sure. Much.
Waiting for them to pull stuff up.
Where is it, Gil? Where? Which folder is it, or where? Is it a new one, or?
I don't either. I'm like, what does that mean?
Speakers.
Use your words.
SciPy. But yeah, that was the guy who wanted me to.
Oh, share with me.
Probably. I hate how Google Drive works.
Already. Happy.
Just need them to
Share.
get this plugged in.
No,
double
maybe,
check.
yeah.
We're trying a different laptop to see if
Here, I'll just send you a link.
because, like,
Yeah,
I
okay.
changed the cables, it's still flickering.
Okay.
So We might need to swap out this decimator, but
I would be shocked if it was decimator.
yeah, that's the only other thing that hasn't been changed out, except for the SDI.
You did the display adapter.
Mm-hmm.
Okay.
Didn't change anything. This is showing it's repeating.
If the link is the same, I found the link. So okay, we can try. What is the adapter? Yeah.
Yeah. All right. Let's see if this fixes the problem.
Okay, I'll find it.
So it could be.
Is there any settings or something? Okay.
There we go. Right.
Yeah, well, we're waiting for, because it was flickering. I mean, it's flickering still, but not that bad.
Did you try the other HDMI port on?
No, not yet.
Because sometimes it gets messed up. Sorry.
That was the blue stuff.
It was literally working yesterday.
So let's, you already tried another SDI? I'm sorry.
No, I haven't yet.
Okay.
I mean, it doesn't seem to be doing the blue thing. Which, yeah, again.
Still doing like a flicker.
Yeah. Could it be the adapter? I have another adapter just to try.
I think it's the adapter. I've tried 3 at this point. This is not our decimator, by the way. It's a little better. Oh, never mind. I think we need to swap this decimator out. It is not ours.
Okay. Do we have more upstairs?
Yes.
Okay.
It's I brought our decimator kit from next door.
Okay,
So
is this up in the storeroom?
Mm-hmm.
Okay. I'll go grab that.
Okay. Okay, I'm just gonna. Okay, well, while we're waiting on that, there is a microphone in here that you guys can use. You can turn it off. There is, if you don't want to use it, there is power at the bottom. You just like 5 more minutes. Yeah, we're gonna swap out this. We're gonna swap out this video converter because there's another AV company in here doing a recording session and they're using theirs, so they use ours. And I think that's what it is.
Check, check. Hey, everyone. We're going to get started in about 5 minutes because they're swapping out an AV converter that actually has nothing to do with Linux. So, yeah. But you've got 5 extra minutes if you, wanted to make sure you were here at the beginning, but you wanted to grab that coffee. You've got that chance now. Otherwise, we'll get started in a few.
hello, hello. Maybe a little closer. Let's try rearranging this. Hello, hello. Testing. Good? Yeah? All right. It's kind of weird to stand with the microphone. All right, welcome to the Ibis tutorial. Apologies for the late start here. I think we've ironed out our AV situation. So yeah, welcome. This is the Ibis tutorial. I don't remember what our long form title is, but we're going to be talking about Ibis. It's a dataframe library. So Ibis, it is an open source project. It's on GitHub. Here are all the lovely faces of people that have contributed and more. There's the link to the repo there at the bottom. Here's some other useful links if you want to take a picture of these for later. Otherwise, we're going to have them up. Project website, GitHub. We use Zulip for inter-project chat. So it's like Slack. If you're familiar with Slack, it's just what we happen to use. It's open source. It's nice. Twitter, one of our maintainers, Philip. I went back. Philip does live streams on YouTube sometimes, which are kind of fun. His last name is Cloud. This is a pun. He likes puns. And we have a LinkedIn too, if you're into LinkedIn. Over here on the right are install instructions. Important note, it is Ibis-framework on PyPI, not Ibis. And on Conda Forge, it's Ibis with all the various backends as hyphens. Yes. Oh yeah, do not install, do not pip install Ibis. Pip install Ibis framework. But we don't need to do that because we're going to be doing everything on GitHub. Oh, did we not have a slide with who we are on here? It maybe got hidden. I'm gonna reorder. There we go. All right, here are the lovely presenters we have here. I am Jim. I'm going to be talking for the beginning here. Philip is over there. He'll be talking later on. Also in the room we have Gil and Nati. They're going to be wandering around helping people. Speaking of helping people, we are going to be doing the software carpentry method here. So everyone should have 2 post-it notes. If you came in late, you might not have them. If you do not have them, raise your hand. All right, 1 person. Oh, 2. Okay, a couple more around the room. Cool. During exercises, when you are done, we're going to want you to put the green post-it note up saying you're done, so we know that we can move on. And if you ever have any problems, please put the red post-it note on your computer. If you don't have problems, please do not put the red post-it note on your computer. People will be looking for those. They'll be coming around to help. All right, going backwards. Okay, so we are going to be using GitHub code spaces for our tutorial. In the past, we've used Binder. This is a nice, easy way to run notebooks online from a repo without us having to host resources ourselves. They're a little bit fiddly, so we're going to be walking through this. Here on the side, we have some GIF images, but I'm gonna go through live. So everyone, look at this link. Please type in that link. Go to that link. Ibis project, Ibis tutorial. I'm going to say that one more time, and then I'm going to move to it myself on the screen, and hopefully everyone has it down. Ibis-project/Ibis-tutorial is the repo. Yes, yes. Okay. So the first thing you need to note is you have to be logged into GitHub. If you aren't logged in, this isn't going to work. You have to be logged into your GitHub account. On the tutorial repo, click the code drop down here. We should see code spaces. We have none. I'm going to create a code space on main, so I'm going to click the big green button. It's going to pop me into a new window. This is going to take a little bit to go through. Okay. While this is cooking, I'm going to go back to the slides. Does anyone need that link again? Wonderful. Okay. All right. Oh, we have a QR code for joining the Zulip as well, if you want to do that while we're waiting. Again, this is not required for the tutorial. This is just how we communicate as a project. So if you want to ask questions later on, reach out. That's our Slack like thing we use. All right, cool. So this is started up for me. There's a couple quirks with VS Code code spaces still. The first one you might notice here is that we are seeing the raw JSON for the original notebook, which is not how we want to see it. The way to fix that is to X out of it and reopen it. some bug in code spaces. There we go. So I am all set up. Oh, make it bigger. Yeah. This, thank you. You answered my question. X out of that, X out of this. Yeah, yeah. Is that big enough? Big enough? All right, cool. Please put your green Post-it note up if you are here, if you have a rendered notebook on VS Code. All right. So this is a one-cell notebook. For those not familiar with the notebook interface, or especially VS Code's interface, it's a little bit different than Jupyter, but mostly the same. To run a cell, shift return. This only cell in this notebook is going to download a bunch of data and set up our resources. Starting up a kernel in the bottom here. When you get to this screen, please run that cell. It's going to download a bunch of things. It's going to set up a Postgres database. It's going to move some files around. All of this is needed for the rest of the tutorial. All right, mine is printed out done at the end, which says we're done. We can let that kind of cook in the background if people are still waiting. Please put up your red Post-it notes if you're running into trouble. Otherwise, we're going to kind of keep going here. So I'm going to go back to our slides to talk through a few things while people finish setup. Okay. All right, so moving on. So Ibis is a backend agnostic data frame library. We're trying to have data frame-like syntax. If you're familiar with pandas, if you're familiar with polars, we are another way of spelling data frame-like things, which is a way of working in the relational model. It's a contrast to existing tools. So an existing method of, say, working with remote Postgres data. We have our Postgres database over here. We have our classic pandas, which we love and know, over here on our local machine. And the traditional way of working with Postgres would be to connect, get a table, slurp the entire table back up into pandas, or at least a subset of it if you're doing a read SQL, and then do everything else in pandas in your local machine. You're doing maybe an initial query to subset your data, and then you're working locally with everything else. This is what I used to do. This is how people often use pandas with databases. It works, it's fine. The downside is you're pulling a lot of data back locally, and you're not making use of your remote engine, which is designed to do these queries efficiently. The Ibis model, instead, here's our Ibis over here on the left, here is Postgres on the right, is a deferred execution model where we're actually making use of the backend. So we connect again, we get the table ratings, we pull back the schema, we're able to construct a bunch of queries locally as expressions, compile them to SQL, execute them, and pull back just the results. So all the execution happens over here instead of locally over here in pandas, and we're only pulling back the results. We're not having to do a ton of I/O. We're making better use of our shared resources that your company might have. If your company has a Postgres database, if they have BigQuery, some existing system that IT has helpfully set up, you can make better use of it while still staying in a database or a data frame-like model with Ibis. Send the query over, executes it, and sends the result back, as I said. What do we mean by an expression? So here are a couple different ways of spelling an addition expression, 2 plus 3. Add here on the right is just what you might write that in Python code. this is what Ibis's expressions kind of look like. We're building up operations over time. We have a table. We're projecting out a column. This might compile to the SQL select A from T. And then you can kind of get them more complicated over time. Adding a projection, adding a new column, select A plus 2. If this is confusing, we're going to be going through this so much during the tutorial. This is what our notebook's going to be about. That is the briefest introduction. Hopefully everyone has got their data done. Is there anyone that is still waiting on data download? Okay. I might start, and we're going to be doing a lot of exposition at the front, and that's fine. Okay. More on the VS Code interface. We have this sidebar over here. There is this helpful file manager. I'm going to collapse it while I'm working so that it's not taking up space. But to move to the next notebook, I'm going to go over here. I'm going to open notebook 1, getting started. And for consistency, I'm going to close the old one. And then we're going to minimize. Okay. Sorry, I'm having a hard time with the mic over here and also being right-handed. I think I can make this work. Okay. All right. Say again? Shh. It is a Mac. That is not it. All right. We'll continue on. Cool. So we are going to start out with an intro notebook talking through a couple common Ibis operations and trying to build up more complicated queries over time. To start, we are going to connect to a database using DuckDB. DuckDB is one of our many backends. It's a fast local query engine. If you're familiar with SQLite is good for transactional queries, building a web app. DuckDB is the SQLite for analytics. It's good for really analyzing a lot of data, doing complicated analytics queries. DuckDB is one of the many backends we support. After you've run your download, you should have a DuckDB database as a file, a DDB file, in the data/penguins directory. We are going to connect to it. In Ibis, the syntax for this is ibis dot whatever the backend is. Here it's DuckDB dot connect, and then there's a bunch of backend specific operations. Here's a file path. If we're connecting to Postgres, it would be ibis.postgres.connect, BigQuery, ibis BigQuery.connect, so on and so forth. So we're going to connection. I'm going to run that. I'm just going to start up a cell. Cool. That normally runs fast. That was VS Code starting up. Wonderful. All right. All backends have a standardized interface. And so one of those methods you might have on a backend object is list tables. If you're connecting to an existing database like DuckDB, BigQuery, Postgres, Snowflake, whatever, you probably have a bunch of tables already existing in a registry. There's something that exists already. Data has been loaded into your system. Here we'll run list tables, and we have one table named penguins. We can take a look at it by accessing it via the table method. This is going to return a table object, an Ibis table object. If I repr that, we're going to see an expression. This isn't very, very helpful for looking at the data, but it is helpful for saying what it's doing. And this is saying we have a table. It's got a bunch of columns, species, island, bill length, millimeters, and then the types, strings, floats, ints. Notice we're not pulling any data back locally. The data still exists in the database, not in my Python process. You can run head on it to take a peek at the data, and I still don't see it. It's building up a larger expression. So we have our original table with all those columns and the schema, and then we have a limit expression, which is saying take the first 5 rows. Nothing has been executed. All of this is just building up a larger Python query expression. We have a deferred execution model, so we don't execute immediately. To get a result, we have all these fancy to methods. So here we're going to take penguins.head as our expression, and we're going to call toPandas to convert that expression into a pandas data frame. This is going to compile a SQL, execute it on DuckDB, pull the results back, and convert them into a pandas data frame to display as the output. So I'm going to run that, and we can see our columns. So the penguins data set is a set of penguins on various islands and species, and then some measurements on them. It's a classic replacement for the iris data set, if you're familiar with that. Good for classification. We can also convert to other things. So here's toPyro. Pyro is another tabular format, if you're not familiar, another in-memory object. Or polars, which is another data frame. Ibis tries to be agnostic to the in-memory containers that people might like. If you like pandas, you can convert to pandas. If you like polars, you can convert to polars. We are an intermediary. We want to be working well with the existing Python ecosystem. All of this is a little bit clunky when you're trying to build up queries. It's a little annoying to have to type 2 polars, 2 pandas at the end of all my queries. So we have interactive mode. I'm going to turn that on by doing ibis.options.interactive equals true. What that's going to do is instead of reppering the expression, like we showed up here, where is it? Things like this, where we have the table and the limit might be project as we build up things. It's going to execute it instead and show the results, or a subset of the results. Where are we? Oh. There we go. So every time you repper an expression with interactive mode on, instead we're going to be executing it and showing a number of the initial rows, just so you can get a brief view of what you've been doing. Cool. All right, penguins is a table. You can show that by doing type penguins. It's an Ibis table. We can look at a single column by using an attribute syntax. If you're familiar with pandas, this should be very familiar. Penguins.species is a column, and the type of it is a string column. Different data types have different column types in Ibis. It's not all column, and so string type column has string methods, float type column has float methods, so on and so forth. Okay. We're going to start moving on to queries, building up things with verbs. So the stuff that you can do to a table to actually get some interesting results. We're going to cover these verbs in order: filter, select, drop, mutate, order by, aggregate, group by, and join. All of these compose, so if you learn a concept here, you can build it up and chain them together into larger and larger expressions. If anyone comes from R, all of this is kind of happily borrowed from dplyr. We're leaning on the work done by the R community that's excellent. Cool. So filter. If we have a number of rows, we might want to select a subset of them by some predicate. Here, we're going to say we want to select only the rows where the species attribute or value is Adelie, which is a type of penguin. So I can run that, and we're only going to get the Adelie penguins. I could change that to, what is another one? I can't remember all this penguin species. Gentoo. To get just the Gentoo penguins. You can also combine filters. So here we're filtering for the penguins that are just on the Dream Island and of species Adelie. And again, if you repper an expression in interactive mode, it's going to execute and show you a synopsis of the results. You don't have to combine filters using AND. You can also pass 2 filters in, or multiple filters in. It's variadic. And those are all ANDed together within Ibis. Just another syntax nicety, if that helps. To see the SQL for an expression, so if we're trying to, we built up this thing and we want to see what it's actually going to execute, you can call Ibis to SQL on it. This is going to compile down to SQL and then, pretty print it out. So here is what that looks like from SQL. Select star from penguins, where island is Dream and species is Adelie. We're going to build up a couple of these verbs, and then we're going to do some exercises. So moving on, select. This is a way to do a subset of columns or to add in new expressions here. So here, let's repper the full, I'm in caps lock, table. It's got this many columns. If we want to take only a subset of them, we want to take species, island, and year, for example, we can pass them in as a select. Species, island, year. You don't have to pass them in as string names. Ibis has got a bunch of different syntax things that work. There's not necessarily just one way to do things. For people that like, or situations that require different ways of spelling things, there are different ways of spelling them. So instead of passing in column by name, you can also pass in column objects themselves. So this works the same. You can even mix and match. It's all the same. Filter, select. Drop is the inverse of select. So select, you pass in the columns you want to keep. Drop, you pass the columns you want to not keep. You want to exclude these columns. So if, let's repper again, the initial, n columns. We want to drop the columns sex and year. We don't want them in our next table. We can call drop to exclude those columns. And again, You don't have to pass in by name. You can pass in the column types, objects themselves, and you can mix. All right. I believe the last one before an exercise. Sorry. Can you say that louder? So the next section is on immutability, and we're going to talk about that. So getting a little ahead, but yes. The question was, do we have the in-place thing? And we'll talk about that. Mutate is the last verb we're going to talk about here. Mutate is a way to add new columns. So far we've been working with existing columns, excluding them, filtering them, selecting them. Mutate, you can add new columns. So here, this is similar to pandas assign, if you're coming from the pandas world. So here we're adding a new column, bill length centimeters, and we're defining it as the bill length millimeters divided by 10. Here is bill length centimeters, tacked on the end here. Here's the millimeters, or bill length millimeters, you can see they're the same, divided by 10. You can also do a literal, if you wanted to assign a single value for all of them. So here we have my favorite number column where it's 41. Okay, on immutability. So we've done a bunch of different stuff to the penguins table. The initial penguins table remains the same. Nothing has changed. All of these things add. Ibis is a deferred expression model. We're not working on data in place. We're building up expressions, and then sometimes we execute them. And so there's no real concept of in place because penguins isn't a reference to in-memory data. Penguins is a reference to an expression that says how to get the penguins data, if that makes sense. So if you want to keep the expression around, you have to assign it to a variable, and then you can build up and compose those things. But there's no way to mutate a table in place. So we've been working with these methods in isolation. So talking about select, filter, drop in isolation. You can chain them together. We can build up more and more complicated expressions over time. This is kind of silly to do it this thing here, but you can select a bunch of columns and then drop another one. So here we're going to select out species, island, year, and bill length, and then we're going to drop year. And that does the right thing. If I was to try to, did I save that to a variable? Let's save it, and then we can take a look at the SQL. And we can see that we've optimized the SQL a bit here. We're not doing two selects. We're doing select species, island, bill length from penguins. Cool. This is a VS Code bug that we noticed right before the tutorial started. How do we? Yeah, you have to click into the cell. Something about the markdown isn't rendering properly on this. It renders properly in a notebook interface. So if you can double click the cell that is hidden between here, and doesn't matter which you choose, there is an exercise, exercise 1. Please, raise your hand or red post-it note if you're stuck on that, but we'll have to render into that. Okay. Exercise 1. Your PI is a cranky American biologist who thinks the metric system is for suckers. Oh no. They demand that we convert all of the existing measurements in millimeters and grams to inches and pounds respectively. The PI is extra cranky this morning, so we had better make sure that only the silly units are visible in the output. Here are some conversion factors. So millimeters to inches, divide by 25.4. Grams to pounds, divide by 453.6. Two ways you might accomplish this. You might chain a mutate call to create new columns and then drop the old metric columns. Or you might use a single select to create the new columns as well as to select the relevant older columns. You can try both ways. And then we'll go through the results later. So give you a couple of minutes to do this. If you have your green post-it on your computer, please take it down. Put it up when you're done. I think we're going to give another minute or two, but just a reminder, if you're done, please put your green post-it on your computer. All right, I think we're going to move on. If people haven't tried it yet, we have solutions that can be loaded using the load magic here. So I'm going to load one way of doing this. This is with chaining a mutate with a drop. So here we mutate in 4 new columns: bill length inches, bill depth inches, flipper length inches, and body weight pounds, defined using the various ratios. And then we drop the original metric units. And we can repr that to show the output. And likewise, we can do this all with just one big select. So we select the original columns, and we define in the new columns, and we just don't select in the metric columns. And we can repr that and show it's the same. Doesn't matter which you choose. No. Sometimes the SQL might generate a little bit different, depending on how Ibis compiles it. But any backend that we're working with is going to optimize these down into identical plans regardless. Here we can see the SQL, and it's the same regardless. So the different ways of spelling, whatever fits your brain better, whatever is more ergonomic for your situation, but they're identical in the SQL generated, and they're identical in the operations performed by the backend. All right. So we've talked about select, filter, drop, and mutate. We're going to do a couple more verbs. So the next one up is order by. Order by reorders your data. So the relational model is unordered as the input tables. We need to order rows. We can use an order by. So here we're going to order penguins by flipper length. We're going to sort them. Default is ascending. If we want to do descending, you can add on the descending method here. So .desc, abbreviating for descending, which is a long word. So penguins.flipper length descending, and it will order them by flipper length descending. So high numbers at the top, low numbers at the bottom. up here, low numbers at the top, high numbers at the bottom. All right, let's select out a subset so we can see fewer columns. So we're chaining an order by with a select. So here we're sorting by flipper length, descending, and then selecting out species, island, and flipper length again. So species, island, flipper length, descending. If you don't want to actually access this via the attribute, the column on the input table, we have the ibis.desc method, ibis descending, that can wrap a column name, and you can pass that in instead. So here we're saying penguins, order by, descending of flipper length, and then selecting these things, which might be a little bit tidier depending on what you're writing. Moving on, aggregates. So we've been doing things so far that operate on rows and columns, but we've been keeping and filtering out to a subset of rows, but we haven't been like reshaping our data in any way. Aggregates are reductions. You take an input column and you reduce them to a single value. Sum takes a whole column and reduces it to a single value. So does mean, max, min, count, various things. You can aggregate a column by calling the method on the column. So here we're going to take the mean flipper length. We're going to get back a scalar value. So the mean flipper length of all the penguins is 200 and some change. You can compute multiple aggregates using the aggregate method, which is aliased as well to ag, since aggregate is a long word. So here we're doing penguins.ag, and we're passing in a couple different aggregates. We're going to take the flipper length mean and the bill depth max. And I can compute them both at the same time. Aggregates are nice in aggregate, but they really shine when you pair them with a group by. Question? Yeah, so the question is this: when you did the mean, it came back as an Ibis type. How would I get that as a float? So interactive mode is on. And so right now when we're reppering, we're showing an expression. Let me save this as a thing. So here is our scalar, just so we have a type we can work with. The type of expression is floating scalar. It's an Ibis type. In interactive mode, that's going to execute and repper nicely so we can see the value, which is really nice when you're building up queries. But in non-interactive mode, it's just an expression. It's just a bunch of Python objects kind of in a big tree. To get it as a result, as before at the top, you can call to one of the various methods here. So maybe I want to do to pandas, which will convert it to the same scalar type pandas would use. Cool. All right. Moving on to group bys. So group by creates groupings of rows, and then you can apply the same aggregate to each group. If you're coming from pandas, pandas has the same name. So penguins, group by, species, and ag. If I was to do here, let's see, let's run that. This is kind of just like distinct values then. But with extra ags, say penguins bill length mean, I'm going to group by species, and this is going to take the mean bill length for species and island. So here are the different groups: Adelion Torgerson, 38, Adelion Dream, 38.5, Adelion Bisco, 38.9, different groupings. All right. You can also add in multiple aggregates for a group by. So here we're going to pass in the same two aggregates we did above, bill length mean and flipper length max, to a group by on species and island. And you can always add more things, more columns to the group by. You can do even more specific groups. So not just grouping by species and island, but maybe grouping by species, island, and sex. Cool. All right, time to use all of these verbs that we've learned to do a bunch more exercises. So exercise 2, what was the largest female penguin by body mass on each island in the year 2008? And exercise 3, what was the largest male penguin by body mass on each island for each year of data collection? As before, please take your green Post-it notes down, put them up when you're done. I think we're going to move on. So loading the solution for 2. The question was, what was the largest female penguin by body mass on each island in the year 2008? So we're going to filter out just penguins that are female in 2008, group by island, and then aggregate body mass max. If I run that, we can see the one column for island, one column for max body mass, isn't it? Solution 2, what was the largest male penguin by body mass on each island for each year of data collection? So take penguins table, filter out for only the male penguins, group by island and year, and then aggregate body mass max. And so here we have 3 columns, one for island and year for the group by, and then the max for each group. Question? So the question is, does the ordering of the operations matter? Like, why would you choose one or the other? Sometimes it doesn't matter. So if functionally, when you chain the verbs, if you think about what they're doing at the table, you end up with the same result, it is likely that the SQL generated may or may not differ, but even if it differs, the backend engine, in this case DuckDB, will compile it down to do the same operations. They will optimize the plan to have the same, physical plan. And so it's mostly around what works best for your brain. Sometimes there might be differences if you put an operation first or second in execution or in semantic meaning. But if the query you wrote got the same result, then it's fine. All right, moving on. Joins are the last verb we're going to talk about. We're going to quick breeze through these. So far all the methods we talked about are on a single table. They either reorder rows, select different columns, drop columns, add new columns, aggregate various things into scalars. Joins are a way of combining multiple tables into a single larger table. Coming from pandas, this might be merge. Other tools have different things. In Ibis, which we try to stick to the SQL model, we call them joins, and the method is join. There are a bunch of different kinds of joins. The simplest is inner join. If you're not familiar with joins, we're not going to go too far into them, but you might think of an inner join as a way of adding extra columns from the right table to the left table as a lookup. And so here, if we have left.join_right, one column in the left, different column on the right, we're going to get rows where they merge together where those two columns match. If the column names are the same in both tables, you can just pass in the single name, and it's fine. We are running a little short on time, so I'm just going to run this exercise, and then we'll do the next ones at the end here, given some open time. So exercise 4, add a new column to the penguins table with the mean mass of penguins found on an island. So here we have a new expression we've defined to get the mean mass per island. So penguins group by island, and then aggregate, adding in the island mean mass. And actually just run that to show. Cool. So here we have, this is the result of that. The question is to join that, so we add a new column with the island mean mass for every row based on its island as a lookup. The way we'll want to do that is to do penguins.join mean mass per island. So we have our left table is penguins, our right table is this expression, which has got 3 columns, and then we want to join on the island column. So we're going to map rows where the islands line, and then we're going to add in this new column for every row. So if we run that, we can see at the end here we have an island mean mass column where the row is the mean mass for that island. So all of these are Torgerson, so all of them have the same mean because it's the same for that island. Cool. All right. One extra bit of the API we haven't talked about yet is Ibis's magical underscore API. So as you use Ibis, Ibis's API is designed to be able to build up queries by chaining together these methods. We have all these different verbs that we know. We can chain them together conceptually. You can filter rows and then group by them, and then aggregate them, and then filter them again. Build up more and more complicated queries. Sometimes you want to be able to access one of those intermediate results, some part of our pipeline that you need to access a column on. You could save it as an intermediate Python value, variable on the end, and then access the attributes. We have this underscore API, which can sub that in so you can keep doing a single method chaining pipeline. This will become way more clear with an example. So these two expressions here do the same thing. Penguins.mutate, we're going to add the length depth ratio, so it's the bill length over the bill depth. This is written the same way that we've written everything before. Explicit references above. Can run that. Fine. If we wanted to use the underscore instead, everywhere where we have penguins, we can replace it with an underscore, which is what we've done down here. So instead of having penguins.billLength and penguins.billdepth, we have underscore.billLength divided by underscore.billDepth. The way you read this is anytime we have an Ibis method, here it's mutate. It might be to select, it might be to filter, it might be to group by, whatever. Where there's the underscore, read it as that table that the method is being called on. So mutate is being called on penguins, so the underscore is penguins. If instead I added a filter in, then the underscore is the output of this whole expression. It's a way to access a bit of the method chaining pipeline. I'm going to drop this back out. They have the same result. They're actually identical at the expression level. And we can assert that by saying t1.equals t2 at the expression level in our graph of expressions that we built up. They are identical. Okay. We're going to have two exercises at the end here. I'm breezing rapidly through so we can get in time for a break. We talked at the top about using toSQL to compile an Ibis expression to SQL so we can see it. By default, that uses whatever engine you're connected to. We're connected to DuckDB. This is DuckDB SQL. Sometimes you want to see SQL for a different dialect. I've built up an expression for DuckDB. Maybe I want to compile it to Postgres. I can pass in a dialect for Postgres instead. And that is going to compile there. Postgres and DuckDB have the same-ish SQL dialect, so they're the same. What's one that might be way different? I don't know, MS SQL. Oh, that's fun. Oh, I don't have that installed, that's why. SQLite. Yeah, a little bit different. Okay. We have a couple open-ended exercises here, and then we're going to take a break afterwards. So I'm going to encourage you to spend a couple minutes on here. Take a break. We'll come back. We'll talk about these after the break, and we'll go on to Notebook 2. So these are exploratory. These are, poke around in your terminal, play with the Ibis API. We've talked about a bunch of the common verbs, the central verbs: select, drop, filter, group by, aggregate, join, order by. That was the one I was missing. Ibis has a bunch of extra methods on here. This was all written for working in Jupyter. As far as I can tell, VS Code doesn't have tab completion. Instead, if you wanted to poke around with that, you do, say, we have penguins, and then you have to wait. If you type tab, it just types a tab. But there's a lot more methods on tables, so you can poke around at those. And there's a lot more methods on columns. So let's do... Say again? Control space. I'm on a Mac. Would the command be space? That is not it. No suggestions. Okay. Oh, did I spell it wrong? Oh, okay. I don't know. Anyway, going through the exercises here, open-ended. Exercise 5, find and read the docstring on the cast method, which we didn't talk about. There's cast on both columns and on tables. Looking at the column one, try casting the penguins.year to a couple different types: float64, string, date, and intdate. What happens for each? In exercise 6, look through the API. We have a link up here to our API docs. find a method, either poking around through tab completion exploratory or looking through the API docs, and try it out. See what other things Ibis has to offer here. You can take a minute now. You can take minutes. We're going to give you a 15-minute break to do both these exercises and break, and then we'll talk about these afterwards. Thanks. I should say what time 15 minutes ends at. Meet back here at 9:20. Hello. Okay, back on. All right, we're gonna get started again. So people could wind back down. Let's talk through our 2 exercises. So first one, casting. So cast method on the column. If I do float 64, the column's originally an int. That works. What if I do it as a string? That also works. What happens if we do it as a date? Oh, question or answer? Can you repeat that one more time? Sorry. Yes. Yes. So the question is, can we do types without doing strings? So there is a D-type thing, which can, this is what actually is being used internally. So here you can cast strings. You can pass in, a Python type like int. There's also Ibis expression data types is that gonna? Man, I'm annoyed by VS Code. And here's all the different types as actual objects. So if you wanted to access them there, we don't export them top level. The D-type thing is usually good enough. But if you wanted to see them, that's where they are. Cool. All right. What happens if I try to cast to a date? Anyone try this? Yeah, it errors out. So here we get an error. This is an Ibis error. This is happening at the expression level. Oh, no, this is happening in DuckDB. Never mind, I'm wrong, and I think I have 2 examples of the same thing then. Yeah, so this is happening in DuckDB. Ibis generates the proper SQL, and then on the engine we error. Yeah, so there you can see the SQL. We're casting it as a date. The engine errors. Same thing happens for int8, but for a different reason. So yeah, we cast it there, but if we actually try to execute it, let's do 2 pandas to get a shorter traceback. Conversion error. You can't cast int64 with value 2007 because it doesn't fit into an int8. It's too big of a number for an int8. Sometimes our casting API is going to error at the Python level. It's going to say you can't cast, this type to that type. Ibis is type checked to say that. But for the most part, it's going to error. It's going to pass on to the backend, and the backend is going to say, this works for us, this doesn't work for us. Did anyone find an interesting method that you want to talk through here? Something we didn't talk about in the, the 7 verbs above. Selectors? You walk through selectors? Selectors, I'm not going to touch on those here because they're a little more complicated, but selectors are a way of generalizing ways of selecting multiple columns. And so ibis.selectors. I don't know, of type, say that. And then we could do penguins.select. And this is going to select all of the integer columns. Or we could do, string. So it's a way of doing that, and instead of having to spell out all the column names, you can get all the columns of a specific type. These can be combined in set notation, so you might do all the columns that start with, fizz and are ints. Anyone try something else? Yeah? Fill null? So fill null is going to fill null values. You might pass in sorry. I'm going to repr so I can get the columns again. So here's all our different columns. Some of them have nulls in them. So like bill length, bill depth. Some of them are strings. We can do penguins.fillNull with a mapping and say fill the values where sex is null with unknown, and maybe we'll fill the bill length as 0, or I don't know, 10. I'm just going to drop where the null values are. Anything else? Oh, yeah.
I was curious, can you use something like this selection approach to say, get all of the floated columns?
The question is, can you use selectors to do them all for a specific D type? You could. You'd have to merge the tables afterwards, but we could do select Ibis selectors of type, what do we have, float dot fill null. Yeah. And so here we're filling just the float columns with 10. Cool. So there's a bunch more things in the Ibis API. We're going to talk through some of them later on, but we're not going to get through all of them. We generally try to expose most of the functionality that is common across lots of backends. So, complicated string methods, numeric methods, more aggregates that we haven't talked about. Encourage you to look through the API later if you're more interested in Ibis to see what other things it has to offer. All right, I'm going to open up Notebook 2, and we're going to move on. So opening the sidebar here, click that, and then open Notebook 2, and we're going to drop Notebook 1. Okay, so far we've talked about one way of getting data into Ibis, which is connecting to an existing database. In the first notebook, we're using DuckDB. We have a DuckDB file. It's a local database. Data already existed in it. We connected. It was there. It was easy for us to access. This would be how if you were connecting to Postgres or BigQuery, Snowflake, MySQL, whatever systems you might have at work. It would work. There are other ways of getting data into Ibis, and there are also other ways of getting data out of Ibis that we haven't talked about. This notebook here is going to be on importing and exporting. So, starting this up. Yeah, in Notebook 1, we loaded data from an existing database, connecting via ibis.duckdb.connect. Different syntax for different databases. The connect method is not standard, it's specific to the database. So for Postgres, you might pass in a host and a password. BigQuery, you might pass in a project ID and a dataset ID. All of these are different ways of getting a connection, and that connection probably has existing tables. So here we're going to connect to the same DuckDB database that we used in Notebook 1. We're using DuckDB because it's both fast and it's local, and that makes it really easy for us to use in tutorials. So connecting to that DuckDB file. Existing tables can then be seen and accessed as we did in Notebook 1 with list tables, and accessing them as a table. All of this is identical to what we did above. Other ways of getting data in. So Ibis has some read methods for reading data from flat files. Sometimes you have data that exists as a CSV or as a Parquet file, as a JSON file, and you want to also, work with that with Ibis. There are two ways of doing this. There are methods on the connection. So above, we created a connection to a DuckDB database, but you can also use the top-level functions as well. Those will use the default backend that's set. We're not going to go too much into default backends, but it's another way of accessing it. Here, we're going to use the methods. So con.read CSV, con.read Parquet, con.read JSON. Exercise 1. So we're going to add a column for scientific name. So above, we accessed the penguins table from our existing database. On disk, we have a CSV file at data/penguin/species. This is, here's the CSV, column for species and a column for the scientific name. Your task is to read in the species CSV as an Ibis table using con.read_CSV, and then join it with the original penguins table with the species table to label every row with its proper scientific name on the species column. So I'll give you a couple minutes to do that. Please use the green post-it when you're done. All right, let's go through a solution. I'm going to type this out rather than loading it. So we need to do two things here. We need to load in a species table. So I can use the read CSV method and pass in the file path. So data/penguins/species.csv. That's going to load the CSV file as a table in this database. And then I need to do penguins.join species on the species column. And that should work. Cool. So we have created a new table from the CSV table, or data, and joined it on the species column. And here we can see the scientific name column, which gives the scientific name for all of the penguin species. Did anyone do this differently or run into an issue where this didn't work? Cool. I talked to one person at least that tried using the ibis.readcsv. So let's just show what that looks like. So ibis.readcsv instead of con.readcsv. And this should give us an error. Yeah. Multiple backends found for this expression. So what happens with this is that the top level read CSV method is going to use a default backend, which is going to be a different DuckDB connection, and you're going to get an error saying that we're trying to join tables across two different backends. We're working on some things in the coming quarters to make this, or months to make this smoother. One way to fix this right now is instead to do ibis set backend and make the connection we created above the default backend. And then this is just going to work. This is just a different syntax for the same thing. Where did that go? There we go. Question? Say again? Yeah. Oh, okay. So there's two things there. One, there's ibis.join, which is just an export of the top level of the same method. It's a different spelling of the same thing. And then here, we have two things named species. Species here is a table. Let's actually, I'll repr that alone. So that is the table. It's got two columns, one for species and one for scientific name. And then here, this is the name of the column that we're going to use to join on. Oh. I don't think it's a keyword argument. I think it's variadic. Yeah. Okay. Cool. Moving on. So we talked about getting data that is already existing in your backend. So here, DuckDB, it's got an existing table named penguins. We've talked about loading data from flat files. We used a CSV to load it in. Ibis can also work with different in-memory data formats. So maybe you have an existing in-memory pandas data frame or Polish thing that you want to also make work with Ibis. The way that works in Ibis is you wrap those in-memory formats with memtable. It's a function that can take in various well-known table formats in Python and kind of coerce them into something that Ibis can use. So here we're going to create a table from an existing pandas data frame with 3 columns called items. Cool, there it is. So 3 columns, item, price, and average weight. We can do the same thing from Pyro or from polars. All of these are different in-memory formats. These are containers. The data exists in your Python process. Some people like polars, some people like pandas, some people like arrow. We try not to take an opinion. And so whatever you want to work as an input, we can work with. We can coerce it into Ibis. Once these tables are wrapped in memtable, they are a table object. So if I do, let's see, orders is the name of one of them. Type of orders is an ibis.table. It's going to work the same with anything else we've already learned. We can build up queries using select, group by, all the methods we talked about in Notebook 1. We can join them together, we can execute them, we can get results. And all of that will just transparently work. So here we're going to find the most expensive item in this product database thing I set up. So items, order by, price descending, limit 1. A little more complicated query, find the product with the most items in stock, and even find the most expensive item per kilogram. Just building up queries with in-memory tables. You can even compose them that make use of different tables. We can do a join between items, which was created from pandas, and orders, which was created from polars. So we're joining two different in-memory containers together with Ibis, and it all kind of works out. When querying in-memory data wrapped in Ibis memtable, we're going to use the current backend, which is DuckDB by default, unless the query makes use of a table attached to some other database. So this query above, all of the data inputs were in-memory data, so we're using the default backend. If we were instead joining with a database or a table from a different thing, maybe we have a Postgres table wrapped in there or something from BigQuery, we're going to execute on that engine. Memtables make it really nice if you have a little bit of lookup data to kind of add that in to an existing query in an efficient way. And how they function is backend specific, how we move the data over to the backend and make it execute. But we kind of try to do that transparently for you. So exercise 2, we're going to add some columns for island coordinates. This is very similar to exercise 1. We're just getting the data from a different source. Here we have a pandas data frame. Your job is to course it to an Ibis table using memtable, and then join with the new coordinates table on the island column so that we have a new row for every island. Give you a couple minutes to do that. Remember, please take down your green Post-it notes. All right, we're going to move on. So working through this one. This is very similar to exercise 1. So I need to do two things. I need to create a new coordinates data frame, taking in, wrapping the original in memtable. And then I need to join penguins.join coordinates. And we're going to join on the island column. Oh. Didn't run the original cell. There we go. Now that should work. Cool. And so we have a new set of columns, latitude and longitude, for each island. So this is the latitude and longitude for Torgerson. Any questions on what we've covered so far? Yeah. So the question is, why can't you pass in coordinates underscore df to an Ibis method, right? Yeah. We thought about allowing that. So taking in, if you're passing in join, allowing you to pass in a pandas data frame or a polar thing or whatever, and we would implicitly wrap it with a mem table. And we decided we wanted to be explicit. So Ibis methods take in Ibis types. Mem table is the only way to take a non-Ibis type and coerce it to an Ibis type. Any other questions? Repeating that in the mic for people that might not have heard it, Philip is pointing out that some backends creating a mem table is not as cheap as others. DuckDB is very cheap. DuckDB is able to read it from in-memory, so it's just an in-process database. Postgres, you would have to pass the data over, and so having an explicit point where you're saying, here is where we're doing this, makes more sense. Okay, cool. So we have talked about different ways of getting data in. You have data that exists on a connection. You've connected to DuckDB, you've connected to Postgres, you've connected to BigQuery. We are loading data from files and slurping it into the database with the read methods, and then we have memtable for taking in-memory data and doing the same thing. Now we're going to talk about ways to get data out of Ibis. We don't want to have Ibis be an island. We want Ibis to work well within your existing tools and pipelines and ecosystems. We want Ibis to be a nice player. And so there's different ways of getting data out. One of them is using writing to disk. So we can write to Parquet, we can write to CSVs. We have a toDelta method for writing to Delta Lake, which is a format for multiple Parquet files as table structures. All of these are methods on queries. So if I have built up an expression, I can call that expression .to underscore the file format, pass in a file name, and it'll write it out. Your exercise here is to take the current Penguins data set, using what we learned in Notebook 1, write a new query that filters out only for each island. So we're going to have 3 new files created, one for the island of Bisco, one for the island of Dream, and one for the island of Torgerson. So you're going to need to do a filter call to filter that out, and then write the query results for that to CSV with a CSV of the same name. You need to do a little bit of looping probably over those islands, filtering, calling to CSV, kind of composing together a bunch of the stuff that we've learned already. When you're done with that, please put your green Post-it notes up. think we'll give 1 more minute for this and then move on. All right, so let's try to collectively write a solution here. So I have a list of the 3 island names. I need to create 3 different files, so we're going to need to do a for loop. So for island in islands, and then I need to build up a query. Query equals what? Penguins.filter. Let's use, I don't remember if I imported the underscore. Let's just make sure. So penguins.filter underscore dot island equals island. So we're filtering out for just the island. And then what? Query to CSV. Let's do, just to have a thing against uppercase file names. And I think that should work. Cool. Let's see if those exist. Yep, there's my 3 CSVs. Wonderful. All right. Besides import or exporting to disk, oh, sorry, question? Yeah, so the question is, could we use a group by to do this? The answer is no. I think if you're thinking in pandas where you can access the groups on the group by object, Ibis doesn't have an equivalent thing. Group by is an intermediate for building up a larger expression, but there's no groups accessor on it. Cool, all right. Besides exporting to disk, we can also export to in-memory containers. We've seen that already in Notebook 1. Oh. Yeah, I don't remember off the top of my head what the... You can do distinct, but is there one on a column or no? There isn't one on the column. Yeah. So penguins dot select island dot distinct. And if I was to do 2 pandas, you can get that as a pandas object. Anyone else? Cool. All right, moving on. Exporting to in-memory data. So we wrote something to disk to get results out. You can also get results in memory. We've done that a bunch already, both by repping to see it as can execute and get the results back to something you can see. But we've also called 2 pandas before in the previous notebook. We have a bunch of different to methods on a query that let you get results back in a container that you can use. 2 pandas for getting a pandas data frame. 2 polars for getting a polars data frame, 2 pyaro to get a pyaro table. There's 2 others we haven't seen already. 2 pyaro batches returns a record batch reader. This is a pyaro structure for streaming results back. This is a way you can iterate over and get batches back. Maybe you have a large query result and you want to slowly stream process it rather than pulling the large result back into memory. And there's also 2 torch, which returns addictive torch tensors if you're doing something like PyTorch. We are open to adding more methods if there's other standard formats that people would find useful. These are ways of trying to coerce Ibis into things that you might use later on in analysis. Maybe you're plotting, maybe you're doing scikit-learn, maybe you're doing something else. You need to get your results back into memory so you can do something else in Python and fit into the ecosystem. So here we have a query, arbitrarily grouping by species and then taking the mean body mass. I can get it back. as a pandas data frame. So here we're calling two pandas, and I can see the type is a pandas thing. Yep, pandas data frame, and there's the result. You can do the same thing with two polars and two pi arrow. So there's a polars data frame, and here is a pi arrow table. All right, last bit of this notebook. There are other ways of integrating with downstream tools. So besides explicitly calling these two methods to get a result back in memory and then doing something else in your analysis, Python has a bunch of standardized protocols that objects can make use of. Some of these are rather old. So a really common one is the double_array method. Libraries like NumPy use this to coerce things to NumPy arrays. Lots of Python things that work with NumPy-like things call NumPy as array or as any array, which will coerce it in. And so you can pass Ibis things to, say, matplotlib, and things should just work. It'll coerce the object to a NumPy array and move on. Likewise, there's a new-ish data frame protocol, which is the same thing but for data frames. Some Plotties libraries use this already. A popular one is Altair, which we're going to show an example of below. And then there's a very new arrow C-stream protocol, which coerces things to arrow tables. The support for these in the ecosystem is growing. These last two, they're relatively recent compared to the dunder array method. But they're all ways that you can have different data frame-like things pass into a library, and hopefully things just work. We're going to make a demonstration of that using the library Altair. So if Ibis is like R's dplyr, or a dbplyr, Altair is like ggplot. And so here we're making a plot of the penguins. We're going to make a chart. So we're going to do a scatter plot of bill length across bill depth for each penguin species. You don't really need to understand the Altair syntax. This is mostly just to show that things work. Note that we are not calling two pandas, to pi arrow, to anything. We're passing in the Ibis table directly. And behind the scenes, Altair is going to call this double_data frame method to coerce things into its own internal format and make things work. Hopefully, over time, the ecosystem picks up that protocol more, and we can have fewer explicit calls to make a query tangible and nicer code. We have time for a couple questions, then we're going to take another short break before Notebook 3. Yeah? I do not. They might already support it. They might not. I couldn't tell you. Oh, sorry. The question was, does pandas support these? And I don't know. Anyone else? Cool. We will take a quick 5-minute break. Yeah, 5-minute bathroom break, water, whatever, and come back here for fill up with Notebook 3. Thanks.
3. Hey, everyone. 2, sorry. Wait. No, 3. All right, we're going to get started. I'm Philip. Let's open up Notebook 3. Whoa, if I know how to use a Mac. Okay, so we're going to close Notebook 2 out. Oops. And then if you go over to the file browser here on the left and open up Notebook 3, switching backends. Close this, get some more space. And let's talk about switching backends. Previously, we've sort of been, futzing around with DuckDB, and there's a lot of fun stuff there. But one use case for Ibis that's pretty interesting and that we've sort of seen a lot in the wild is that people want to kind of work locally with their data, or at least work with a subset of that, iterate quickly because things in the cloud tend to be a little bit slower than things not in the cloud, and then sort of get rid of the sampling and run that thing on the cloud. And so we're gonna walk through sort of how that looks here with the IMDb data set. So the IMDb data set is a snapshot of these like films and ratings from, I think it's called the Internet Movie Database. It's already downloaded for you. You did that in the setup in Notebook 0. And let's just make sure we've got what we need here. All right, so we've got 2 Parquet files, title basics, a sample of title basics, and title ratings. And basics is just sort of name for all the metadata about specific titles. And then ratings are like individual ratings for a particular title. So we're going to kind of work with these Parquet files like we saw in the last tutorial. We're going to load them, and then we're going to work with a subset of that, which is this other sampled Parquet file. So let's first do some imports, turn on interactive mode. We're going to connect to DuckDB, and then we're going to load in that Parquet file. Similarly to what we saw with read.csv, we have con.readParquet as a method. I don't think we talked about this before, but you can give the name, you can give the table, the Parquet file that you're loading as a table, you can give it a name. And so here we're naming it IMDb _title _basics. We could see we sort of evaluated that. We got the preview. We've got tconst, title type, a bunch of columns here. You can sort of scroll over and see what all is here. Start year, end year is adult, genres, etc. We'll talk a little bit more about what's going on here in a bit. Tconst is perhaps a little bit important here to notice. It's just sort of a number-ish thing that uniquely identifies a particular title. We're going to load the ratings table and do kind of the same thing, and we see that the table's a lot more narrow. It's just it's got tconst, the average rating, and basically the denominator of that vote. Of those ratings, so 2,036 people rated whatever tconst, 0001 something. Cool. We're going to jump right into the first exercise. And the first exercise is just to join basics with ratings on the tconst column. We'll give people a couple minutes to get that done. And remember to put the post-it notes up when you're finished. Okay, since we covered joining quite a bit in the previous couple of notebooks, so let's move right along. We're going to load that solution up. Nothing too fancy here. We just sort of call join, basics.join ratings, and we join on the tconst column. And so we've got the ratings along with this additional metadata about the title. Next exercise is to keep the join, and then we want to select out only a subset of the columns here. So title type, primary title, num votes, average rating, and is adult columns. Give people a couple minutes to do that as well. All right. Kept the join, and we called select with specified column names. Nothing too wacky happening here. You know, camel case is a blight, and so let's get rid of those. And they're also not PEP 8 compliant, and they're maybe a bit clunky. So let's modify the previous thing we just wrote to turn them into snake case. Just as an example, that for title type, that's sort of inserting an underscore, you know, after title and lowercasing all the characters. There's a couple ways you can achieve this. We haven't explicitly talked about rename, but it's a good opportunity to sort of try a method like and see if you can sort of figure out how to use it. By the doc string, there's a bunch of examples in there. You can also modify the select that we used above to sort of do the relabeling in one method call there without calling rename. So let's take a couple of minutes to do that as well. Just show the previous solution in case people want to see it. just out of curiosity, how many people used rename? Okay. How many people used select? It's everybody else. Okay, not that many people. Interesting. So if you did rename, there's sort of a, I guess like a somewhat cheeky thing that maybe it's a bit of an Easter egg here, or a snake egg. I guess we're writing Python, so you can pass this like special string in snake underscore case, which you will sort of do the thing that was required in the exercise. There's a couple of other ways you could do it with rename. This is probably the shortest. And then the select way is sort of kind of using keyword argument syntax here to just say, well, title type is this, etc. I should probably evaluate these all so that things don't break later. I guess for this it doesn't really matter. Cool. All right, so now we're getting into a little bit meatier thing here. We're going to use the above joined table, and we want to compute the 10 non-adult movies with the highest average rating, having received at least 100,000 votes. So let's take a few minutes for that. Okay, let's see what we did with exercise 4. Compute the 10 non-adult movies with the highest average rating, having received at least 100,000 votes. So here we're starting to get into a little bit more complicated things and building on what we learned in the last exercises. So we've got the join and the select and the rename from the previous 3 exercises. We've got a filter here. We're taking only movies. We're keeping it family friendly by removing adult films, and we're making a comparison to the number of votes a particular title has received. We're then sorting by the average rating and then getting out the things that we care about. So what does that look like? Okay, we've got City of God, Star Wars Episode 4, Psycho, a couple of other movies, some recent ones like Oppenheimer. Yeah. Oh yeah, go ahead, sorry. Great question. The question is, when you have multiple filters, does it compute it all in one pass, or does it do it multiple times? And one of the very nice things about SQL databases is that since you're handing it the entire thing, the entire expression, the whole SQL statement, it's going to choose the most optimal way to evaluate that expression. Unlike, say, pandas, where you'll do a filter, it's going to evaluate the filter, give you back a series, and it with the next one, evaluate that, et cetera, et cetera. With a database, it actually has access to the whole thing that you're doing, and so it can do fancy things like basically create a function that sort of applies all the predicates and across all the rows, kind of in one go. So the answer is no, it does not apply things successively like that, which tends to make it a lot more efficient. Yeah. Question? No, that is just the specter of backwards compatibility haunting us. Oh yeah, sorry. So the question is there a difference between passing a list of these predicate expressions, or passing it sort of as each individual one as arguments? And yeah, the answer is that we started with the list. Somebody requested to not have to put brackets there, which is completely reasonable. People had already written a bunch of code with the first thing. Yeah. I think somebody else had their hand up, or was... No? Okay. Sorry. Yeah. I think I saw you. Yeah, go ahead. Yeah, so you can negate filters here. So we can just look at like not movies, which is going to include like TV shows and I don't know, a bunch of other stuff too. You can't negate a string column. You can negate, however, a Boolean column. And that'll give you a bunch of stuff. One Punch Man, great anime. Schitt's Creek, Cobra Kai. Okay, we have just a bunch of TV shows at the top, it looks like. Arrested Development, good stuff. So the answer is yes, you can do that. The question was, can you use a tilde to negate Boolean expressions? And yes, you can. That's right, yeah. So you could cast this to a Boolean instead of doing 0, or there's any number of other. Yeah, so Ibis is generally a little bit, it follows sort of the databases, not the specific database, but it's more strict in what you're allowed to do with it. Sometimes, like you can do some things that you can do in pandas, like summing a Boolean column. We don't like require you to cast to an int and then sum. Sorry, there's a question in the back, I think, first. Yeah. Sorry, I can't hear you. Do I see? Sorry, I didn't. Louder. Yep. Oh,
The problem description says that we need to limit it to the top 10, so add a new top 10.
thank you. Yes, okay. Right, so we're asking to people to limit it to 10 and, of course, not following. Right, exactly. Do as our tutorial says. So the main difference is that there's no longer like an ellipsis at the bottom, and that's there to indicate that there's more than 10 rows. So you don't start thinking you have a lot less data than you actually have. Yeah. Yeah, we should be able to write like Sol 3 or whatever I think it was here, like that. Yeah, you should be able to do that. Yeah, computers are annoying. Okay, you guys are asking the most difficult questions. They're the questions with the most complicated answers. The question is there an index and can you do slicing? And the answer to the first part is no, no, there is no index, and sometimes you can do slicing. It's, for the most part, most of our backends support a way to do what's called like a limit offset, if you're familiar with that in databases, which is essentially providing the bounds for a slice of rows. Because the relational model is like rows are sort of arbitrarily ordered, you need an order by for that limit offset to actually make sense. Otherwise, you're just gonna get essentially a random set of those rows. Let's see if we can do that here. I don't know how to use anything. Okay, cool. I mean, we might be able to just do like, like you can take the first 5, like that. DuckDB does support like dynamic offsets, which actually allow us to provide this kind of slice syntax as well. So you can do that. We try to make it work on all the backends. Some of the backends are determined to make things not work, and so we cannot force them in all cases. But the API is there. Yeah, go ahead. Yep. Interesting. This query. Okay. It's possible. Okay. The top 2. Oh, for movies. Okay. Yeah. So they might actually have the same rating. In which case, yeah. So they both have 8.6 as their rating, and so therefore, are we sorting by average rating? Yeah. So therefore, like this is it's a partial sort because 8.6 sort 8.6 twice. Like it doesn't. It's sort of the database is going to see that and say, hey, it doesn't matter what order I emit it in because 8.6 is equal to 8.6, and so I don't need to reorder. I'm just going to emit those rows in whatever order they come out in. Make sense? Okay, cool. Other questions? Awesome. Absolutely. Primary, if I could type. Apparently I can't type. Oh, caps lock, amazing. Primary title. Well, I probably want to put primary title second. If I could, okay. Just because I don't actually care about primary title except to resolve ambiguities. So capital C comes before capital S, so we've got City of God before Star Wars. Yes, yep. Not how I would have chosen it, but hey. All right. We will get to why switching backends is important and relevant. Gil.
Why doesn't that look like the top 10 list on IMDb?
I can't answer that. Why doesn't that look like the top 10 list on IMDb? Yeah. Okay, we're gonna talk about expression portability here for a second. Let's turn off interactive mode. Set it to false. We've built up solution 4 here. Let's just make sure that I haven't edited it. Possible to say. Okay, cool. We're here. We've got stuff. That expression is still sort of bound to the backend that we created it with, which was DuckDB. We have a method called unbind, which is like, hey, just like supplant that with nothing. Like, get rid of the backend that is sort of underlying this expression. You can think of it as sort of generalizing it a bit. It's no longer specific to DuckDB. It's just this abstract sort of soup of computation. So what does a repr look like for that? Okay, let's maybe can we zoom out a bit? Let's see. Yeah, okay. Just so we can get the whole thing on here. The way you can sort of read this is from top to bottom. At the top, you've got your kind of base tables, IMDb title basics and ratings. The next operation in our sort of expression graph is sort of a join. There's some details here about how Ibis works that are not super relevant for sort of understanding why switching backends is important. But we've got a join here, and then on top of the join we did a filter, and then on top of the filter we did a sort, and then on top of the sort we did a project, and finally we wrapped up with a limit 10. And the main difference here is that instead of like what we see when we had the bound expression was basically we had like a database table, and that was from I think notebook 1 or 2. But here we've got unbound table. Yep. Okay. Thank you. Good. Okay. So we've got unbound table now instead of database table, and the expression is sort of independent of what we use to create it. So this sort of brings us to the point like, well, what if we had like a different backend connection? Not just DuckDB or SQLite. What if we had something that was like a proper server? I don't know, let's try it out. Let's see what happens. So we've connected to Postgres, and let's see if we've got some stuff in here. Oh, funny that we have the IMDb title, basics, and ratings tables in here. That's very promising. We can't really call X2 pandas, right? Because we've like sort of ripped out the back end. It's not bound to anything anymore. But we still have that expression that's totally abstracted away. We have our connection here with a toPandas method, and that takes an expression as its first argument. And remember, this is not attached to DuckDB anymore, totally independent of really any backend. And we can actually just run that and wait for some time. And we've got a slightly different answer, which is kind of interesting. Does anyone want to speculate on why that is? You are not allowed to. Yeah. Yes. Yeah. So the data in Postgres are a bit different. And so, right, we got a slightly different result. It's possible maybe my expression changed a bit. Oh, okay. Yeah, so the data are different. DuckDB is a subset, and so we get a slightly different result. But we were able to sort of build all of our code in DuckDB locally. We didn't have to think about servers or clouds or whatever. We built that locally, and then once we got our connection to the server thing, we just said, hey, like, please compute my expression. Yeah, go ahead. Yep. Yes, to save you the suffering of having to set up Postgres, we put that in the container and started up and loaded the data in there for you. Do you mean like connection parameters here? Is that what you're saying? Like host and all that stuff? I believe we're using the default, like Postgres. If you just run like pSQL or whatever, it has a couple of it has defaults for all the things like connection parameters, and I think we're using that here. But yeah, of course, like you could say host, my DB or whatever. Well, that's not going to work here, but. Next question. Somebody raise their hand. Yeah.
So these expressions, like once you unbind the expressions, when you go to a new package, it could generate a slightly different expression, right? You get issues where like the analytic engine is slightly different, so you get different answers.
Oh boy. Yeah, let me repeat the question. So the question is, when you switch backends, like, can you get different answers that are not related to like us putting different data in the database? Like maybe you'll get a different SQL statement or something like that. There are a few cases where things get weird. A few. There's some. So in this case, so that was using like the DuckDB syntax. If we change this to Postgres, we see that some stuff is different, namely like, actually I guess I should somehow figure out how to put these side by side. Let's just hack for a second. I can't use computers. Okay. Cool. All right, let's put DuckDB explicitly in here, run that. So you'll notice in DuckDB we've got some casts, okay? And then in Postgres, I think we do not have those casts. And that is Ibis sort of knowing about what the database needs to kind of make that thing work. I think like there's also like we recently added support for null ordering or null placement when you order, and so like in DuckDB there's like a certain default behavior that matches with our API, and in Postgres it's like, well, no, you got to say nulls last here. That's like, those aren't actually even the most interesting differences. The weird stuff is when you get things like, oh, Postgres uses this library for decimal arithmetic or floating point arithmetic, and DuckDB, Postgres uses this library, DuckDB does it this other way. They don't match because like floating point arithmetic is, doesn't satisfy a bunch of useful mathematical properties. Especially when you're sort of doing stuff in parallel, things tend to get kind of weird. So it's complicated. Or it depends, I don't know, take your pick. Yeah.
I want to talk about what backend guarantees the aims we have for cross-practice for expression.
Yeah, that's difficult to pin down. So what do you get when you are sort of like caveats aside on I guess what I'll say on floating point arithmetic, you should be able to take two expressions and compare them and sort of get the, do sort of equals on them and get, equivalent results. I would say that's maybe the main thing there. Yeah. Yeah. Oh man, okay. These questions just keep getting more and more complicated. Okay, so the question was, do you have anything to turn SQL into Ibis? And the answer is yes, and it's very experimental. Very. Okay, so that's not the same question. The question was, if you sort of just want to run a bit of SQL on your Ibis expression, can you do that? Maybe renaming or something like that. If you just need to do renaming, that specific example, you should use rename. But in general, yes, we actually have a much less experimental way of like running arbitrary SQL against an expression. It's in the next notebook. So that'll be fun. Question? Yep. Like right here? Yep. Okay, so the question is, does Ibis like do any checking for like, accidental like foot guns or, running up your snowflake bill or whatever, that sort of thing? The answer is no. If you do this, we assume that you mean what you say and you are going to want to execute that whole expression and get it back as a data frame. When you're in interactive mode, we always put a limit 10. It's a limit 11. Anyway, that doesn't really matter. We do prevent the foot guns in interactive mode because that tends to be a thing where people like run, as opposed to sort of like it's a little bit more effort to get to this point than to do the interactive thing. So, yeah. Yeah. Good. Thank you. Okay. Let's move on to should we take a break? Let's take a 5-minute break. 10-minute break? Yeah. Regroup at 11. we're going to get started. Same deal. We're going to close notebook 3. And we're going to open notebook 4, playing with PyPI. And I can click on the right thing. All right. So we're going to investigate some stuff with PyPI, which is the Python package index. Seth Larson has a GitHub repo that each release contains gigabytes of stuff, which is the PyPI data. It's sort of package downloads, like for the individual download level. It's pretty neat. It's rather large, so it's kind of fun to play around with a subset of that in Ibis. And we're going to use DuckDB again. Imports, interactive mode. We're going to connect to DuckDB. And we already downloaded this data on your behalf in notebook 0 or 1. I can't remember which one. And we're going to use read Parquet here to load that all into our connection. And we're going to name them, sort of the file name without the .parquet bits, so deps, maintainers, etc. Okay, that was pretty fast, which is nice. Now let's see what we've got available. The things that we said, deps, maintainers, etc. Let's pull out these things into variables. Okay, we've got deps here. This is, I believe, package dependencies. So each row is a dependency of a package, and then some information about how that dependency was specified. So, for example, whoever named this horribly named package 0-orchestrator has a dependency on AIO Redis. It looks like it was following good software engineering practices and having a completely unbound version. So it's bound to work in perpetuity, of course. And then these are all the other dependencies here, etcd3, jinja2, etc. Let's look at maintainers. Okay, we've got people, and I think there are also corporations and probably other conglomerates of things. And we've got package names that they own, stuff like 0-0-1. And 00 print-lol. Great package. And then a bunch of things that are just zeros. Okay, let's look at packages. This is sort of like individual package metadata, right? So each row is a package, and then it's got a version, like what its required Python version is. It looks like a bunch of these are just the empty string. Whether that version has been yanked, whether it has a binary wheel, has vulnerabilities, pretty useful, and some timestamps, downloads, scorecard. Not sure what this is. We're gonna poke around and look for people who are doing weird stuff. Thing called typo squatting, which is taking advantage of honest mistakes. You type pip install, and you end up with some other thing that's not the thing you thought you typed. And most of the time, honest mistake, right? Most people aren't like pip installing, insert vulnerability here, but as you can see, like PyPI has a ton of packages. Like just in this data, so let's just count these and see what it says. Type. All right, so 500,000-ish packages, and this is a subset of the data, right? It might be fewer if there's like repeat versions and so forth, but we're probably talking about hundreds of thousands of packages here. Ibis is here to sort of help you out, sort of. It's not going to prevent you from installing things incorrectly. But we can at least investigate this data set and see, are there sort of ways we can understand whether, people are publishing packages that they probably shouldn't be. So Strings have a Levenstein method, which will compute the Levenstein distance between basically the column you're calling it on, and an argument. In this case, we want to get the package name that is listed on PyPI, and then we want to get the sort of similarity between that package name and pandas, and we're going to sort it by that similarity. Okay, so we've got pandas, of course, and sort of the Levenstein distance, kind of inverse. So lower numbers mean more similar. We've got a bunch of awesome packages like F pandas, I pandas, K pandas, M pandas, pandas, panda, pandag, pandan, pandac, and probably a zillion other things that sound like that. Maybe these are legitimate projects. I mean, PAA-NDAS is pretty sus. Pandac, yeah, also a little weird. Pandaw might be in there. Who knows? Let's play around with some other methods. We've also got a Jacquard. Oh, sorry, there is a Jacquard function in DuckDB. We do not have a Jacquard method. So what are we going to do? Well, we're going to use something called a UDF built-in. And these are motivated by the fact that databases have a zillion and one bits of functionality that are either super niche or just kind of, I don't know, just super weird. Okay, is anyone familiar with SoundX? Okay, a few people. Good times with SoundX. So let's see what that looks like in DuckDB to sort of pull in some of these slightly more niche pieces of functionality. Jacquard takes 2 strings and returns a similarity measure between 0 and 1, so it's a little bit different from Levenstein, and we're going to use that to sort of do something similar. And the way you write this is you write ibis.udf.scalar.builtin, bit of a mouthful, and then you specify the name of the function, the arguments. These names don't particularly matter, their input types, and their return type. And then you can put whatever you put here, nothing will happen. This is just saying register this function sort of to Ibis with this name and these types. So let's actually run that code, okay? Now that's defined, we can actually call it, and we can call it with Ibis expressions, we can call it with Python things like a string, or sort of whatever thing makes sense. We couldn't call this with 2 integers because the inputs were defined to be strings. And it doesn't make sense on that, so Ibis will give you an error. But we can't call it as a method, we call it as a function. So let's do that. We got some other interesting results. DSNAP, probably not related to pandas, or DSNAP, I don't know what's SPANDAS, Spanda, NASA DAP, this sketchy looking thing. We've got some other thing, we've got actual oh no, that's, okay, I read that and thought that was pandas. That's PADNAS. Pandanas, that's a great package name. And then actual pandas is barely scraping, the 10th row here. So exercise 1, let's swap out Jacquard for a different similarity. Question? The question is, if you run that, you get different results every time you run it, or potentially different results every time you run it. And that is because we're sorting by similarity, which is only a partial sort, because a bunch of them are equal to 1. Let's see if that happens here. Yeah, so now we got NASA DAP first, and PSNDAS, or whatever that is. Question? Sorry, the question is why is that the case? I don't know actually. It almost certainly is an aspect of whatever the implementation of Jacquard is. There is that, yeah. Pandas is similar to pandas. Okay. You have one with pandas 0. Okay, well that's pretty fun. Definitely can't answer that discrepancy. Any other questions? Yeah. Yeah. Good question. Yep. So the question is like how does this work? How are we calling the right Jacquard? Like, what are you doing? Like, did you just write a thing for this now? No. So you were speculating on how, like, is it the same name with the same types? And that's exactly how it works. We have like an object that sort of stores enough information so that when you write an expression like that, it's basically a UDF call, and then we can look at that in the expression tree and basically, inline that SQL. If you called this something else, what we don't do is validate that you actually are referring to a function that exists in the database. It turns out that listing all of the functions that are callable in a database is really difficult, especially when they have type systems that have variadic input and different argument overload. Anyway, it's a whole thing. But if we called this like, jarred, which is not a function that exists in DuckDB, and we tried to call that, like DuckDB is gonna be like, hey, scalar function with name jar does not exist. Did you mean add? Of course I meant add. I hope not. The question was, is it using Jacquard distance to determine what you meant? And I don't think so. Okay, let's go back to this. And I forgot how to spell it, so I'm just gonna do undo. Thank you. Okay. No. Okay. That's right. That's right. There's a couple of there's a thing you can do like if you want to call it as Jacquard and it's called something else that's like annoyingly long or whatever, then you can rename it or whatever. We're not covering that here. Yeah, question. Yeah, so I don't think we're getting into that here, but it's yeah, you can write like. Oh yeah, sorry. The question was, can you kind of use this same syntax for like functions that actually have an implementation defined by you? Is that the question?
More so like say you had a Postgres PSQL function.
Yeah. Uh-huh. Oh yeah, you can. Yeah, you can. As long as you can like spell the only actual requirement is the name, of course, and then that the return type is specified. You can actually leave off the input arguments, but we're sort of doing that to not get bogged down in all the complexity here. But yes, you can do that. All right. Oh, sorry. Yeah. Nothing, because we don't do anything with the body of the function. There are ways that you can do stuff like this. Let's I think we call it Python. And then you could this is like let's see, I don't even know if this will work. It might work. Cool. So now I just define Jacquard to be 1 for everything, which is a terrible idea, but like that it's sort of similar syntax here. Now let's go back to that, redefine it, call that again. All right, let's do some exercises. So swap out Jacquard for different similarity function. There's a link to the similarity functions. Let's see if I can open that up. Prevented pop-ups. Anyway, the link's there. I forget what else is there. I think there's like Jaro-Winkler similarity, Levenstein, Jacquard, probably some other ones. Let's just take a couple minutes to do that. think we're going.
Which maintainers are the most downloads? Those are just using.
I think we're.
We need to make sure we do the .SQL one.
Yeah.
And
Maybe we can skip this one, or yeah, I think we probably.
oh, that's the exercise. Maybe you just show that exercise. Okay, so just do a demo for exercise 4.
Sounds good. Yeah. Doesn't matter. All right. So one possible solution, possibly given away by the title of the file, is to use Jaro-Winkler similarity, which is called Jaro similarity in DuckDB. And sort of redefine that or define it, and then we've got another string similarity thing, and we've got some of our friends here, iPandas, duplicate. I'm not even gonna with that. Pandan. There's Pandas 2 and 3. So Pandas 2, I think, is actually an official package. No idea what Pandas 3 is. Probably don't install that. All right, let's dig around some more. Exercise 2, which maintainers have the most downloads? Which package maintainers on PyPI have the most downloads across all the packages they maintain? Take a couple minutes to do that one too. Oops. That's a bad idea. All right, so I think this one is maybe a little bit more complicated. Let's see what's happening here. Yep, we need to do a join, right? Because we've got maintainers in one table, which is sort of just a list of people and the packages they maintain. And then we've got package metadata, like the package name and how many downloads it has, etc. So the first thing we're going to do is to join maintainers with package, and we want to join them on 2 keys. Package name one, and then name on the other. Then we're going to group by name, which kind of there's package name and name. Name is actually the maintainer name, and then we're going to sum all those downloads per maintainer. Get out the things we care about, which is name and downloads. Order by downloads descending, and then limit 10. We say okay, we didn't say limit 10. Okay, we have the inverse of the problem we had before where we said do it and then we didn't do it. Anyway, now we're just adding one. So that's fun. So what does that look like? So apparently the person named AWS maintains a lot of stuff. anyway, you can have organizations and so forth in here. We've got AWS with, I can't read the number, 2 billion, 2.4 billion downloads. Google again, Microsoft. Jericho is an actual person doing apparently a lot of work. Donald Stuffed. This might be someone too. Azure SDK also working really hard here. Did anyone like sort of take a different approach than sort of joining group by aggregate, et cetera? Cool. Moving right along, exercise 3. What packages depend on Ibis framework? You can also use any other package you're interested in. So let's take a couple minutes to do that one. And there's a hint here, which is you can sort of use the distinct method, which will it's sort of like drop duplicates in pandas, if you're familiar with that, but it'll give you the duplicate entries removed from a table. All right, let's take a look at a possible solution to exercise 3 here. Right, so we've got the deps table, and then we can say like, okay, what packet, which package depends on, Ibis framework by looking at the dep name column and filtering to only that, that package. Get that package name out and then compute the distinct columns. Let's actually run that, and then bunch of stuff that looks fun. Okay, Big Frames is a Google project. Cap Cruncher, great name. No idea what it does. DKDC is a package by the product manager who works at Voltron Data on Ibis. Fugue warehouses related to Fugue. Interesting. No idea what it does. Single store DB. Let's not talk about that. Ibis ML, machine learning for Ibis. Mismo is like entity resolution. ML, LLM, really hard to pronounce. Also interesting. Okay. All right, let's move on to the next thing. Using .SQL as an escape hatch. So I think this person here, you asked about something like this. If you could sort of put SQL strings, into you get Ibis to sort of help you there. And the answer is yes, and there's actually a few ways that you can use this. Sometimes you need to do this because of, I don't know, Ibis doesn't expose a thing. One of your colleagues was like, I hate Ibis, here's a pile of SQL, make it work. Backend specific functionality that we haven't exposed, number of reasons. So let's start with the simplest thing here. We're just gonna like run select 1 + 1 against like the database, right? And we're gonna get back like a table, right? So we've got 1 + 1, cool. All right, we're confident our database can add 2 numbers. Very, convincing. Yeah. We can, we can rename the thing. Comes back as a table with 1 row, 2. Maybe don't do this as like your daily driver calculator. There are better things to use Ibis for, and also better calculators. So now we've got a name. It's like, well, okay, can we refer to F on that thing? And it's like, well, yeah, we definitely can. Let's just change that to make sure that we preserve the original F, etc. Good times. You can mix and match, which if either your coworker like doesn't like you, and or you just like want to live in a world of pain where you're like going back and forth between SQL and Ibis. This is there if you need it. You should probably be very sure that you need this before you use it, but you can do it, okay? Which is pretty nice. What are we doing here? We took select. We added, we sort of updated that F to be F + 2. Then we called alias, which sort of tells the backend, hey, this whole Ibis expression before that, that's T. And so now I'm going to call SQL on that Ibis expression and like do SQL stuff on that. So Postgres uses caret symbol for POW. Like this also is like a little bit wrong, right? So F, like we added 1 to 1, got 2. We added 2 to that, got 4. And then we said F like caret 2 and we got 6. So that's kind of weird. Like 4, to the power of 2, not 6. What happened? Postgres uses a funky symbol that I guess no other database uses, or yeah, maybe some other database, but DuckDB doesn't, and we're running on DuckDB. Of course, SQL being like a rigorous standard that every backend adheres to, the caret symbol in DuckDB means XOR, and in Postgres it means power. But we don't actually need to yeah, go ahead. I'm trying to speak in my sarcasm voice. So Ibis can help you out with that too. Maybe your coworker is like, I gotta have the caret. If it's not a caret, you're fired. So we're gonna keep the caret, and then we're just gonna say, hey Ibis, consume this as Postgres. Cool. Now we get a reasonable answer, which is fun. I think we're gonna just sort of quickly go over the exercise 4, and then we're gonna leave time for questions and a few things that we want to talk about. Yeah, go ahead. Which? Yep. Yeah, so it depends on so the question is, can you use stored procedures? Yeah, so you can if it sort of makes sense in a select statement. The only limitation here is that this sort of returns a value, which is a weird thing to say about SQL, but basically it needs to be a select statement. So you can. That's right. Yeah. So you can use And we have other, we are not showing this here, but we have other methods that you can just like dump a raw SQL string in, like anything, like create, insert, whatever, store procedure calls. It doesn't really fit well with like chaining together like things that return values, but yeah. Okay, so top 20 most transitively dependent on packages, that's fun. Are there limits on what you can pass to .SQL? I mean, well, actually, I feel like this person just touched on it. Yes, basically your input needs to be a select statement of some kind. It sort of needs to end with that. And the reason there is like we need to know the schema of the expression. And so we can usually get that from the database pretty easily. But here's an example where we're passing something called a recursive common table expression, which is often how you sort of traverse things in SQL. If you're not familiar with this, like it's a fascinating topic, kind of gonna melt your brain probably. But yeah, you can do like real recursion in SQL, no limits. So that's fun. And like you can definitely sort of run that with Ibis. And there you got an Ibis table from this mess. And now we can see like, I forgot what the question was. Top 20 most transitively dependent on packages. So a bunch of these packages are like, you know, very common dependencies. Whoa. Redis, AIO Redis, you know, Python date util, yeah, makes sense. Adders, click, exif read, probably if we're looking at images. ffmpeg Python, wow, that's terrifying. Yeah, so there you have it. The solution to the problem there is to take that expression and kind of use what we've learned here, like do a group by on the dependency column, count the unique dependents, sort, and then sort of look at what you want. And then we've got a whole bunch of exercises here, but we actually wanted to ask you guys some questions, and I think Jim here is gonna take over for a second, like 11:33.
Yeah, we can do this and maybe leave those to go. Okay. Cool. So we forgot to at the start. We've given this tutorial a couple times. We're trying to do better and better every time, but one thing that helps us is to understand better our audience that we give it to. So this is a quick show of hands survey. It can be yes or no questions. If it's yes, raise your hand. Just trying to get a general vibe for the room. So first, how many of you have ever written SQL for your job? As part of your job, part of your working on, write SQL. Okay, most of the room. How many of you have not? That might be an easier way to get it. Okay, just a couple. Is there anyone here that has not used a dataframe-like library before? Pandas, polars, something like that? Okay, everyone's very familiar with those. Wonderful. Because job titles are vague, I'm going to talk about kind of tasks to see what you do. So first we're thinking about like data scientist-y like things. You have a lot of data, you write a query, you get a small insight into it. You get a small, mean of a thing, group bys, whatever. You're not moving a lot of data around. Does that describe what you do? Data scientist, analyst, something like that? Okay. Other bucket, data engineer. You might have a lot of data, you do a bunch of transforms, you write it out to a different thing, different format, kind of ETL-like jobs. A few people? Okay, how many of you are working in an academia type institution? Wonderful. Okay, and then everyone else, how many of you working in industry? Would be cool. All right, how many use a database system at work? Okay, how many use more than one database system at work? Okay, 2, 3, 4, you poor souls. Okay, cool. Thinking about the categories of these, how many of you are using something traditional relational like Postgres, MySQL, MS SQL, transactional web thing? Okay, wonderful. What about the big data engines, the BigQuery, Snowflake, or something self-hosted like Trino? Okay. How about some non-SQL things like Spark or Dask for doing large data analysis? Okay. How many of you are mostly working with data on your laptop locally? Okay. How many have ever run into size or performance issues with pandas or polars or something like that, your local data framing library? Okay. And then last one, how often do you have to rewrite code you wrote on some local system for a different deployment system? Or a different way of phrasing this is, how often do you write code that you hand to your coworker that then they have to do that? Okay, cool. So one of the reasons we're asking some of these questions is there's a bunch of different use cases for Ibis, a bunch of different why would you use Ibis? And it really depends on what you're trying to do. And so some of these are, you don't want to have to rewrite your code. I develop locally on DuckDB, I develop locally on pandas, and then we deploy on BigQuery. And that's a use case that might resonate with some people and not with others. Others use Ibis for access to a fast local engine. DuckDB is really, really, really fast. It'd be nice if we could use that without having to write SQL. That's another reason you might use Ibis. Others just want to be able to access the 4 or 5 different database systems they have at work under one thing without having to know all of the different SQL dialects and connectors and things, just a standard tool. And so trying to figure out what we're tailoring our tutorials for and what the kind of user base we're talking to helps. Anyway, one last thing on this, and then we're going to hand this back to Philip. You all have Post-it notes. We've been using this entire tutorial. If you have comments, things that you liked, things that you'd suggest, any amount of feedback, please write them down. We're going to collect these at the end. It's going to help us get better as we go. Anyway, we're going to Philip back up here. Thank you.
We will read them all, definitely. All right, we're gonna just sort of go through a couple of other interesting, fun bits here. Let's look at a histogram of maintainer counts. We're gonna get to some actual plotting here, which is pretty nice. Okay, pretty cool. So lots of that 500 and something thousand packages have one maintainer. I feel like we should put the XKCD in here for that, but we didn't. But anyway, yeah, so this thing drops off real quick. So let's take a look at that, what that looks like. Kind of weird. I mean, not sure what's going on at 26, 24. Sorry, I can read. But yeah, and we're in log scale on the y-axis, so that's fun. What's going on with that spike at? We got a spike at 12 too, right? Like this is sort of what's going on here. What's the deal with the spike at 12 maintainers? All right, let's sort of get into that here. So the question is, how did we choose the subset we're working with? I think it was the day that we happened to write the tutorial was the day's it was probably the previous day's data from the I think we linked the Seth Larson repo PyPI data. Yeah. Question? I saw a question over here. Okay. Right. So we can sort of poke around here and see what's happening. A little bit here about interactive mode. You can alter the number of rows that we show. Most of the time, let's see, if we go up here, we're only showing 10 plus an ellipsis if there's more than 10. But you can alter that value there, and so we're going to do that here. And not a whole lot of code here. Group by the package name, count the maintainers, and then just sort of pull out what happened at 12 there. And it's okay, Bob something has a lot of packages. I guess I don't know. I don't remember actually what was going on here, but this there's clearly there's probably an organization, if I had to guess, 12 people are in the Bob DB or Bob whatever organization. Then we've got, I guess last time FTW showed up. You got somebody got FTW. Well, let's see if we can adapt here and just put Bob here. Well, the variable name is incorrect, but whatever. Okay, so I don't think we should adjust that. Oh God. Yeah, of course, because right. So bunch of packages that start with that Bob prefix 48, so that's fun. And then we can look at the maintainers here, which is not actually FTW packages, but there are apparently, yeah, 12 people. I guess that's 12. We can count. Yeah. So there are 12 people maintaining, like, that sort of work in that organization probably. You know, it's these people. And yeah, I think that's all we have for today. But happy to answer questions. We got plenty of time. Thanks for coming, by the way. That was a lot of fun. Yeah. Oh, thank you. Oh, God. Okay. You know, at some point that the answer to that question will be lost to history, hoping that occurs sooner than later. So the project was started by Wes McKinney in 2015. He named it Ibis before releasing it. I don't think there was ever any sort of explicit, like, this is why it's called Ibis. There are a few pictures of, like, ibises on Impalas, which like, Impala was Cloudera's SQL engine, and Wes was working there at the time, and so it was like Ibis's ride on Impala. Anyway, that was sort of the... Ah, well, yeah. Yeah, I mean, ibises as an animal are, like, quite annoying in some places. So I don't know if we want to be, you know. Yeah. Okay. Okay.
There's a sacred word of Thoth, which was the god of words and such in ancient Egypt. So there you go.
Okay. All right. We'll use that one. Yeah. We'll definitely take. Yeah. We'll definitely take name suggestions, although, you know, no promises on anything happening there. Yeah. Yeah, so people who speak languages where, like, I's are pronounced like E, like in Spanish, often pronounce it that way. So yeah, no, that we can definitely do. Yeah. Renaming, you know, who knows? Yeah, oh God. Okay. Yeah. Any questions? Any other? Yeah. Go ahead. Yeah. So the question was, it sounds like you're using. I actually don't know how to Vax. Okay. Vex. I think it's VAEX is the way the project is spelled. It is also like a tabular library for computing, and, like, sort of how does Ibis compare? Is Ibis good for large data? So I personally have not used Vex, so I don't know exactly how it compares. I think it probably, in terms of, like, API, is probably similar. I mean, tables only admit so much API flexibility. So I mean, I can only speculate on that. Ibis, on the other hand, for sort of large databases, large data sets, it's going to depend on the backend you use. We use DuckDB a lot because it, like, works locally, and it can basically scale to whatever you've got on your hard drive. We've got a number of other backends that are sort of like, you know, the next level up in scale, like BigQuery, Snowflake, and then we've got some stuff that's sort of, you know, in the middle, or it's going to quite heavily depend on how you've structured the database or what the data are. Like Postgres, for example, in certain cases it's going to do really well, in certain cases it's not going to do well at all. So Ibis itself doesn't limit the scale that you can get to. It's sort of designed to work with whatever scale you've got. Yep. Yeah, so the question is there a way to ship like a minimal sort of dependency version of Ibis? The question is, the answer is, you cannot, not all of Ibis's dependencies are optional. All of the ones that are specific to a backend are. So things like rich is a required dependency. Pyro, and there's a couple other lighter weight ones. But we sort of decided to make a trade-off between people being able to pip install a thing and like have a good experience without having to list like 7 things that they want. And you know, the trade-off is that some things are required. But certainly something like rich is not, you know, it's maybe a bit up for grabs and could be made optional.
It's also extremely small compared to Pyro.
Yeah. So some of these sort of drown in the size of Pyro, for example. But yeah, if you're, yeah. Go ahead. Yeah.
I don't think the answer is no, but you can't do joins across data from different packages.
Yeah. So the question is, can you do joins across data from 2 different backends? I feel like I'm answering every question with "it depends." We do not have we do not allow that. In fact, if you try to do that, I think Jim showed an example of this earlier, where it was like multiple expressions found, multiple backends found in an expression, and we sort of enforce that everywhere. We do have some public APIs that you can use to like tie this thing together, that involve like emitting, you know, Pyro record batches, and you can sort of stream that all into DuckDB because it knows how to. Anyway, we can talk about that. I can. It's possible, but like in very limited circumstances, and we generally do not allow that in Ibis. Yeah. All right. Awesome. Thank you for coming. And don't forget to write feedback on the green and red Post-it notes. And we also have stickers. So please come get some stickers with various different kinds of logos on them, old and new.
Yeah.
We also have a couple of talks. I don't remember what they are. When are they?
Thursday morning.
Thursday morning?
There's one. If any of you works with geospatial data.
Here.
Yeah. So on Thursday morning, I think it's 10:30. I should know because this is my talk, but I don't recall exactly. On the geospatial track, if you work with geospatial data and you want to know like how use Ibis plus DuckDB spatial, I'm going to be talking about that. And on Friday afternoon, Gil is going to be giving like a general talk on Ibis, and then you will learn probably a little bit more than what you learned today. But I think it's like you learn like plenty today. I think. I'm doing that too, yeah. What was that? What was her name? Does she have a name? You had like this is like a better explanation of the Ibis. That guy, and you get Ibis. And, oops, and you get that.